Navigation is without a doubt one of the toughest ATPL subjects. It's that one area where even a tiny calculation mistake can cost you some really critical marks. So in this breakdown, we're going to dive into the 5 most common nav errors that trip up even the best students, and I'm going to show you the exact techniques to sidestep them. Let's get right into it.
You've been there, right? I know I have. You spend hours and hours studying the theory, you absolutely know your stuff, but then, under the pressure of that exam clock, one little slip-up costs you points you should have gotten. And man, is it frustrating. But the good news is, it's totally fixable.
So we're not just going to list off the problems today. I'm going to give you some practical, repeatable techniques that will help you build solid habits. The goal is to turn these common traps into guaranteed marks on your next exam.
All right, first up is a real classic, the wind triangle trap. This one is so fundamental because if you mess this up right at the start of a question, guess what? Every single calculation you do after that is going to be wrong.
Okay, so this is the one distinction you have to burn into your brain. Heading is simple. It's just the direction the aircraft's nose is pointing. But track? That's the actual path your aircraft is carving over the ground. And what's the difference between them? It's always the wind. Your heading should be your desired track, but corrected for that wind. Mixing these two up is the root cause of so many lost points. And why is this such a big deal? Well, because everything, your time to a waypoint, the distance you've covered, and most critically, your fuel burn is all based on your speed over the ground, your ground speed. If you accidentally use your true airspeed without factoring in the wind, your numbers are going to be wrong. It's a guarantee. So the fix here really just comes down to simple discipline. Before you even touch your calculator, sketch out a quick wind triangle. Seriously, just draw it. This forces you to actually visualize the problem. And here's the rule to lock in. If the wind's coming from your left, it's going to push you right. So to fight that, you have to turn into the wind, to the left. If the wind's from your right, it pushes you left, so you correct by turning to the right. Always visualize it first.
Okay, error number 2. This one is a procedural mistake, and it's all about getting your steps in the wrong order. I'm talking about the classic magnetic mix-up.
See, we've got 2 different errors we have to account for here. First up is variation. That's the geographical difference between true north and magnetic north. Then you've got deviation, which is the error caused by all the magnetic fields inside your specific aircraft. You have to apply both of them, but the order you do it in is absolutely non-negotiable.
And here is the only correct way to do it. Just think, true to magnetic to compass. T, M, C. You always start with the true heading that you get from your chart. Then you apply variation to get your magnetic heading. And finally, you apply the aircraft's specific deviation to find the compass heading you actually need to fly. Any other order is going to give you the wrong answer every single time.
Let's move on to error number 3. This one's about misusing one of the most powerful mental math tools a pilot has, the 1 in 60 rule. It is brilliant for making quick corrections in the air, but it is so easy to fumble under exam pressure.
So what's the core idea here? It's actually a beautifully simple ratio. It gives you a fast, reliable way to estimate your track error. If you've flown 60 miles and you're 1 mile off track, that means you have a 1-degree track error. 2 miles off after 60 miles, that's a 2-degree error. Simple as that.
But just knowing your track error isn't quite enough. You need to know how much to correct to actually get back on course. The formula to find that closing angle is this. You take your distance off track, you multiply that by 60, and then you divide the whole thing by the distance you still have left to fly. That gives you the angle you need to turn to perfectly intercept your original track right at your destination.
But here is the classic trap with this rule. If you only turn by that closing angle, what's going to happen? Well, you'll just start flying a new path that's parallel to your original track. You'll never actually rejoin it. To get back on track, you have to turn by that closing angle plus an angle to correct for the wind that pushed you off in the first place. A really common rule of thumb is to just double your correction angle. That'll get you back on track nice and quickly, and then you can reduce your correction once you're reestablished.
All right, moving on to error number 4. And this one isn't just about exam marks. This has some serious real-world safety implications. I'm talking about the altitude illusion, and it all comes down to temperature.
This diagram here shows the danger perfectly. Here's what's going on. Cold air is denser than warm air. So think of it like it's heavy. It squishes all the pressure levels in the atmosphere closer down to the ground. Now, your altimeter is basically just a pressure sensor. So when you fly into a colder air mass, it senses a pressure that it thinks corresponds to a higher altitude. And the result? Your altimeter overreads and you are actually flying lower than you think. This is a huge factor in controlled flight into terrain or CFIT accidents, especially when you're flying in mountains.
And this is where that classic aviation mnemonic that every pilot learns comes in. From high to low, look out below. This phrase is a lifesaver. It works for flying from a high-pressure area to a low-pressure area, and it absolutely works for flying from a high-temperature area to a low one. In both cases, your true altitude is going to be lower than what your altimeter indicates.
So how do we correct for it? Well, the rule of thumb is that your true altitude changes by about 0.4% for every 1 degree Celsius you deviate from the International Standard Atmosphere, or ISA. So let's put that into perspective. Say you're flying at 10,000 feet above the airfield, and it's 10 degrees colder than standard. Well, you're actually 400 feet lower than you think. 400 feet! That is a huge, huge deal, especially in terrain.
And our fifth and final common error is a flight management mistake that I like to call the static ETA trap. This really comes from having a set it and forget it mindset about your timing.
There are two big mistakes we see here. First, calculating your estimated time of arrival using your airspeed instead of your ground speed. And second, just assuming that the ETA you figured out before takeoff is the final word. In the real world, conditions are always changing, especially the wind.
The fix is to start treating your ETA as a living, breathing number. It's not a static value you calculate once. The professional habit, the one you want to build, is to use your current ground speed to recalculate your ETA at every single waypoint. That's what real flight monitoring is all about.
So let me ask you this. You're flying along, you do a check, and you realize your ground speed is significantly lower than planned. Your ETA is slipping. What two things should you be checking immediately? The answer is your watch and your fuel gauges. A slipping ETA isn't just about being late, it's a direct warning about your fuel consumption.
Okay, so let's do a quick-fire summary. Number 1, always visualize the wind problem first. Draw it out. 2, always follow the correct order. True, magnetic, compass. 3, master the 1 in 60 rule for smart corrections. 4, remember that colder means lower. And number 5, your ETA is a dynamic number, so always update it using your ground speed.
You know, the bottom line here is that mastering these checks isn't just about getting a better score on an exam. It's about turning these complex problems into simple automatic habits that are going to make you a more precise and ultimately a much safer pilot.
I really hope this breakdown helps you feel a bit more confident with your navigation calculations. If you found this useful and you want more practical tips to help you ace your ATPLs, you know what to do. Make sure you subscribe. Thanks for watching and fly safe.